Welcome back, everybody. Today we're going to learn about solving equations with variables on both sides. Let's start with discussing some steps to help us solve. The first thing we want to do is eliminate or get rid of any parentheses or brackets or grouping symbols. But most often they're going to be parentheses. The next thing we want to do is combine like terms. On the same side of the equals or of the equation using either adding or subtracting, whatever it is that it tells you to do. Then we'll move like terms across the equal sign using adding or subtraction opposite operations. We want it to be so that we have non-variables on one side and variables on the opposite side. And then our last step is to isolate the variable. Using multiplication or division. Let's try some. Example 1. I don't have any like terms on the same side, but I do have variables on both sides, so I want to move them to the same side. I'm going to move the 4x. The opposite of subtracting 4x is adding 4x to both sides. Bring down the 10. Negative 4x plus 4x add to 0. Negative 9x plus 4x is negative 5x. Now we can isolate the variable or get x alone. Right now we're multiplying negative 5 times x. The opposite is to divide both sides by negative 5. 10 divided by negative 5 is negative 2. So x is negative 2. Example 2. We do have parentheses here, so I'm going to start with distributing. 3 times 3x is 9x. 3 times 4 is 12. So we're subtracting 12 on the left. 1/4 times 32 is 32 over 4x. And 1/4 times 56 is 56/4. You can simplify right away with those if you're okay with doing that in one step, or you can do it like I'm doing on here and have 2 steps. 32 over 4 simplifies to 8x, and 56 over 4 reduces to 14. Now I can work on putting like terms on the same side. I can move my x's together, and I'm going to do that by moving the 8x over. This is a positive 8x. The opposite is subtracting 8x from both sides. 9 minus 8 is 1x. Remember, you can put the 1 there if you want to, but typically we don't put a 1 in front. Bring down the subtract 12. The 8x minus 8x is 0, so that goes away, and we have positive 14 left on the right. I want to finish getting x alone by moving the 12 over with the 14, its like term. The opposite of subtracting 12 is to add 12 to both sides. Bring down your x. Negative 12 plus 12 is 0, equals 14 plus 12 is 26. X equals 26 is our solution. Please do number 3 to show in class tomorrow. Sometimes we get special solutions to our linear equations. They're either going to be infinitely many solutions or no solutions. So how do I know when I have one of those? When an equation is true for all values of the variable, then your answer is infinite many solutions. And so what does that look like when we're solving? It looks like 4 equals 4 or -7 equals -7. But the biggest thing that you're going to notice is that the variable eliminates out or completely disappears. The other thing that you could notice is maybe as you're starting to simplify, you get 2x minus 3 equals 2x minus 3, where you have the exact same equation on both sides. Any of these are examples of when your answer would be infinitely many solutions. No solution is exactly the opposite. When an equation is not true for any value of the variable. So what that would look like is 10 is equal to 7. 10 is equal to 7 is not true. So that doesn't work. -4 is equal to 11. That is not true. So there is no solution. And again, the variable will eliminate out usually. Or you might notice instead of the 2x minus 3 equals 2x minus 3, maybe you have 2x minus 4 is equal to 2x plus 11. The variable part is the same, and so you know they're going to add to 0, leaving you with -4 equals 11, which is not true. Let's try a couple. I'm going to start with distributing to eliminate the parentheses. 3 times 5x is 15x, plus 3 times 2 is 6, equals 15x. I'm going to move my variables to the same side for like terms. The opposite of a positive 15x is a negative 15x, so we're subtracting. 15x minus 15x is 0 over here on the left, leaving us with a positive 6. And 15x minus 15x is 0 on the right. We do want to go ahead and write that 0 down. And we see 6 is equal to 0. That is definitely not true. So this has no solution. For number 7, we'll again start with distributing to eliminate those parentheses. -2 times 4y is -8y, and -2 times +1 is -2. And we don't have anything to change on the right side. Some of us might say right now, well, look, -8y minus 2 equals -8y minus 2. That's true. It's the exact same on both sides, so I know I have infinitely many solutions. But we could take this a little bit further just to double check, and we want to move our y's together on the same side. So the opposite of a -8y is a positive 8y. So if I add 8y on both sides, -8 plus 8 is 0. We bring down the -2 equals -8 plus 8 is 0. Bring down the -2. This is a true solution. So infinitely many solutions, IMS, infinitely many solutions. Please work on 8 and 11 in the U-Try for next class. And on our last page, we have steps for solving linear equations. Step 1. Let me make that better here. Distribute to remove grouping symbols. Then we simplify the expression on each side of the equal sign. Collect variable terms on one side and constant terms on the opposite side. Isolate the variable. And then our last step should always be to check your solution, just to make sure you didn't accidentally drop a negative somewhere or add rather than subtract. Because sometimes I know for me, I'll write adding and I accidentally subtract because I'm looking over on the other side at the original operation. So this is just reiterating what we were talking about earlier. Solving real life word problems. Always want to practice, pardon me, a little bit of this. So we're talking about a boat traveling upstream on the Mississippi River for 4 hours. So the return trip only takes 2.8 hours because you're traveling with the current. How far does the boat travel upstream? Well, we know that the distance going upstream has to equal the distance going downstream, because they didn't say it was any different. I'm going to make our variable x equal the speed upstream. And let's see what we have. Some speed times 4 hours, because upstream was 4 hours, equals distance downstream. Well, the speed was 3 miles an hour faster than the downstream. Or upstream, sorry. The speed was 3 miles an hour faster. So upstream speed plus 3 for 3 miles an hour faster, and it took 2.8 hours. So let's figure this out. X times 4, 4x. Over on the right, we're going to distribute that 2.8. So we have 2.8x plus 2.8 times 3 is 8.4. I want to move my x variables to the same side. This is a positive 2.x. So I'm going to subtract 2.8x from both sides. 4x minus 2.8x is 1.2x. 2.8 minus 2.8x adds to 0. And we bring down that 8.4. Divide by 1.2 on both sides. And we get x is equal to 7. So the upstream speed is 7 miles an hour. So if it's 7 miles an hour and it took 4 hours to get there, then 7 times 4 makes that distance 24 miles upstream and downstream. Please give number 13 a try. At least get it set up if you can, and we'll discuss that more next class. Thank you so much, and we will talk with you next time. Have a great one.